Hello dear student, I welcome you all. I am Mrs. Sujata Tarle from KK Polytechnic Nasik. In this video, we are going to discuss about the formation of differential equation. So how to form the differential equation from the given relation? So the first step is find the number of arbitrary constant present in the given relation. So it is the first step. So arbitrary constant means a constant to which one may assign the different values according to the specified conditions is called as arbitrary constant. So the first step is find out the number of arbitrary constant which are present in the given relation. Second step, differentiate the given equation number of times exactly equal to the number of arbitrary constant present in it. Third step, then eliminate the arbitrary constant from the equations. An equation independent of the arbitrary constant is the required differential equation. So these are some basic steps to form the differential equation. Now we discuss the examples. First example is form the differential equation if y square is equal to 4ax by eliminating the arbitrary constant. So here given relation is y square is equal to 4ax. So it is the given equation. So from that we have to form the differential equation. In this equation, a is the arbitrary constant. So there is only one constant. So we have to take the derivative only once. So the first step is differentiate with respect to x. So the derivative of y square is equal to derivative of 4ax. Just take the derivative of both sides. As we know, the derivative of y square is 2y into dy by dx. Derivative of y square is nothing but this 2y into dy by dx is equal to, here 4a is the constant term. So just write down this 4a first and then just take the derivative of x. So the next step is this 2y, derivative of y, that means dy by dx is equal to 4a and the derivative of x is 1. So 1 into 4a, that is equal to 4a. So there is only one arbitrary constant. A is the arbitrary constant, only one arbitrary constant. So we take the derivative only once. Okay. Now the next step is, after taking the derivative, the next step is we have to eliminate this arbitrary constant. So to eliminate this arbitrary constant, just use this relation. So we have given that y square is equal to 4ax. It is the given relation. And from that, find out the value of this 4a. So 4a is equal to, just transfer this x to this side. So we get 4a is equal to y square upon x. Now the next step is, just put the value of this 4a is equal to y square upon x in this equation. So just put here the value of 4a. So we get here this 2y dy by dx is equal to, and here put the value of 4a. 4a is nothing but y square upon x. Next step is simplify this term. So here y is multiplied. If we transfer this term to here, so it becomes only y. So we get 2 dy by dx is equal to y upon x. And transfer this x to this side. So we get 2x dy by dx is equal to y. So the required differential equation is 2x dy by dx minus y is equal to 0. So the final differential equation which is free from the arbitrary constant. So it is the required differential equation. Second example, form the differential equation from the relation y is equal to a into e raised to mx. So solution is, the given differential equation is y is equal to a into e raised to mx. So just note that, student, here a is the arbitrary constant. A is the arbitrary constant and here m is the fixed constant. So the first step is, there is only one constant, arbitrary constant. A is the arbitrary constant. So there is only one constant. So just take the derivative only once. So differentiate with respect to x. So we get derivative of y, that is dy by dx, is equal to a is the constant. Just take the derivative of e raised to mx. It is nothing but dy by dx is equal to a as it is, derivative of e raised to mx, that is e raised to mx, and again take the derivative of mx. It is the composite function. So just again take the derivative of mx. So we get here dy by dx is equal to a into e raised to mx as it is, and just find out this derivative of mx. M is the constant term. So just write down this constant term first and then take the derivative of x. So the derivative of x is 1. So 1 into m, that is equal to m. So now here we take the derivative. Then next step is, we have to eliminate this arbitrary constant. A is the arbitrary constant. We have to eliminate this arbitrary constant. So for that, use the given relation. So we have given that y is equal to a into e raised to mx. So just use this relation and here put the value of this a into e raised to mx as y. So we get dy by dx is equal to this m as it is, and this a into e raised to mx, it is nothing but y. So just put this total value is equal to y. So dy by dx minus my is equal to 0. So it is the required differential equation. Third example, form the differential equation whose solution is y is equal to a cos 3t plus b sin 3t. So we have to form the differential equation of this relation. First step is, write down the given equation, that is equal to y is equal to a into cos 3t plus b into sin 3t. Just note that, student, there are the two arbitrary constant. A and B are the two arbitrary constant. That means we have to take the derivative for the two times. Just take the derivative for the two times. There are two arbitrary constant. Then take the derivative for two times. Now here t is the variable. Y is expressed in terms of t. So t is the variable. So just differentiate with respect to t. So we get here derivative of y with respect to t is equal to a is the constant term, derivative of cos 3t plus b is the constant term, derivative of sin 3t with respect to t. And it is nothing but a is the constant term as it is. The derivative of cos 3t is minus sin 3t. But here it is the composite function. So again take the derivative of 3t. Plus b is the constant term as it is. Derivative of sin 3t is the cos 3t, and again take the derivative of 3t. So we get here this dy by dt is equal to a as it is minus sin 3t as it is, and the derivative of 3t. 3 is the constant term and the derivative of t with respect to t. Derivative of t with respect to t, that is 1. And 1 into this constant term 3, that is equal to 3. Plus b cos 3t as it is, and the derivative of 3t with respect to t is nothing but 3. So we get dy by dt is equal to minus 3a sin 3t plus 3b cos 3t. So it is the first order derivative. But there are two arbitrary constants. So again take the derivative. So again differentiate with respect to t. So we get here derivative of dy by dt. Again take the derivative of this. So we get derivative of dy by dt is equal to minus 3a is the constant term, derivative of sine 3t plus 3b is the constant term, derivative of cos 3t. Now just simplify this term. So derivative of dy by dt is nothing but d2y by dt square is equal to minus 3a into the derivative of sine 3t, that is cos 3t. And here sine 3t is the composite function, so again take the derivative of 3t, derivative of 3t plus this 3b as it is, derivative of cos 3t, that is minus sine 3t, and again take the derivative of 3t. So we get here d2y by dt square is equal to minus 3a cos 3t as it is, and the derivative of 3t with respect to t is nothing but 3, plus 3b as it is minus sine 3t as it is, and the derivative of 3t with respect to t is 3. So on simplifying this, we get d2y by dt square is equal to minus 9a into cos 3t minus 9b into sine 3t. Now the next step is just taking out this minus 9 as a common. So we get d2y by dt square is equal to minus 9. Just take this minus 9 as a common. So in bracket we get here a cos 3t plus b sine 3t. And we know this a cos 3t plus b sine 3t is nothing but y. So just use the given relation. A cos 3t plus b sine 3t is equal to y. So just put this value. So a cos 3t plus b sine 3t, that is equal to y. So we get d2y by dt square is equal to minus 9. And the value of this bracket is nothing but the y. So d2y by dt square. Just transfer this minus 9y to this side, so it becomes plus. So d2y by dt square plus 9y is equal to 0. It is the required differential equation. Thank you.